Welcome to part 3 of our live training session here with our Sport Front Wheel Drive Acura Integra. In the last 2 tutorials, we completed the base map creation process. This tutorial, we're going to get the engine to fire up and run. We're going to check our timing with a timing light, verifying that the M-Tron has been synced to the engine so that it understands the position of the engine and where to command the fuel and the spark to happen within the auto cycle. We're also going to go through some basic fuel and spark timing tuning and idle control tuning here so we can get the engine to fire up and run and maintain and hold its own idle. This is always the first step in the calibration process. We have a lot to cover. Let's jump in so we can check this out. Welcome back to our live training session here with our Sport Front Wheel Drive Acura Integra. Now, in the last 2 tutorials, we built our base calibration file. We're now ready to get our engine to fire off in this tutorial, looking at things like our idle control, sorting out our fuel and airflow modeling in idle conditions, and then checking our timing with a timing light, making sure that the M-Tron is synced between what it's commanding in timing and what the engine is actually receiving in timing. We need to do that with a timing light, and we're going to go through that process here in just a few minutes. Now, the first thing I want to do is just a basic overall check of all the things that we've added and configured into our M-Tron. We can use our ECU runtime value parameters to take a look behind the scenes as to what is going on and making sure that everything is configured right so that when we fire up the engine, we're going to have things performing as we'd expect. So let's jump in and take a look. We need to go up here into our utility section and into our ECU runtime. And this allows us to take a look at all of the parameters that are going on in the background. So anything that we've wired in, any calculations that are being performed, we can see what the statuses are going to be for particular features or functions. We're going to start off here in our engine sensor section, and this is going to allow us, it's the very first thing to the left, it's going to allow us to take a look at the basic sensor configuration. So let's just dive in here and make sure that everything looks like it's reading properly. So the manifold pressure is showing here about 100 kPa, that's right, for key on engine off right now, we're right around sea level. We take a look down here, engine coolant temperature showing 18 degrees Celsius, inlet air temperature showing 20 degrees Celsius. Now there is a deviation right here, that's okay on a cold engine like this. I usually see that the engine coolant temperature reads a little bit lower than the ambient temperature outside because the sensor is submerged in fluid and it just seems to always have that trend. That's nothing to worry about right here, so we'll keep moving on. Our charge temperature is showing here 18.7, 18.6. Now the charge temperature is taking a look at the coolant temp and the air temperature. And specifically at idle and low RPM conditions, it biases more towards looking at the coolant temperature for the air density when it's going in and we're working with the speed density mode. This is going to allow us to ignore a heat-soaked air temp reading, which can skew what our final air mass determination is going to be. We know that air mass is volume times density. The volume is coming from, and the estimation of airflow is coming from our main VE table. The density portion is coming from things like our barrel pressure correction and our air temperature. So the air temperature reads a certain temperature back to the ECU. That is going to be a way that we can determine density. So volume times density is air mass, and that's how we calculate and determine air mass. Now, taking a look at this, we're finding here that the charge temperature is 18.7, and the charge temp ratio, the blending ratio between our air temp and our coolant temp, that's how it gets this value right here. So the charge temperature is actually what it uses in the actual VE or the air mass calculation to determine what the air mass is going to be. Okay, so moving down here a little bit further, we're going to find that we have our exhaust manifold pressure. We're using that in our efficiency calculation. We've set this to do a map over EMAP relationship. It's going to constantly compare the two and figure out a percentage of deviation or difference between them as we find that we turn up the boost pressure. If our manifold pressure starts to get too high on a turbocharged engine like this, it can affect our engine efficiency and affect what the fuel delivery is going to be to our engine. So we're building this right into our airflow and fuel model. We're using it as part of our actual efficiency calculation into our main VE table here. So we can see that that's reading and it's calibrated right. We see it's here at about 95, 96. So we're looking at both of those. Those are calibrated correctly. Now throttle position right now is showing 0%. I'm off the throttle. If I go here and I open my throttle, it's showing approximately 100%. So we went through the calibration scaling for the throttle position and that looks accurate. Now the ECU is showing here 17.57 volts. I need to go in and actually take it off the 16 volt charger. It is on the charger right now, and that's why the voltage is high. It is a 16 volt battery with no alternator, so we do have to keep it on the charger and make sure that the battery is charged up when we're actually running the engine.
The baro pressure showing 98.83 kPa. We should find that the baro pressure and the map pressure are pretty close to each other. They're within 0.2, 0.3 kPa, which is very, very close, and they are going to be accurate. Now the baro pressure is on board to the M-trunk, so it should always read accurately, but we're finding here, we can see what that's going to look like. Engine oil pressure is showing 0.7 kPa. Now the engine hasn't fired up and it ran at all, so we have no oil pressure built. We'll see what this shows when the engine actually starts to run. Engine coolant system pressure showing 2.4, 2.0 kPa. There's no coolant pressure built because the engine hasn't ran. If we see a spike in coolant pressure, they could indicate we have a bad head gasket or something wrong with the head lifting. We're not worried about any of that right now, but we do see that it is going and showing a valid reading, so the sensor is calibrated right and it is working properly. The lambda is showing 1.22 lambda, that's full lean. Wideband is on right now, so it's powered on. The heater cycle, the heater circuit, and the sensor itself has heated up and the sensor is reading accurately. So once we fire off the engine, this should be a good value to look at. Looking down here a little bit further, we see fuel pressure. We see the fuel pressure showing 0 kPa. This does have a mechanical fuel pump on it. It's a Weldon mechanical fuel pump that's driven off the camshaft. This allows the fuel pressure to be very stable because the pump itself isn't tied into any kind of electrical demands, no kind of amperage demands as we'd find with an electrical pump. This is very, very consistent for fuel delivery. So we should find once we get the engine to start to crank over and run, we have the fuel pressure reading and showing 0 kPa for key on engine off. So that looks good. So we're gonna go ahead with that. Engine air mass, this is going to show us all the status of anything going on with any air mass calculations. Nothing here is really important right now. Torque calculations don't.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.